Hello! Today, we're going to solve an interesting problem involving sequences and sums. By the end of this video, you will be able to evaluate the sum of a sequence by identifying its periodic pattern. Let's look at the problem. We are given a sequence defined by the rule a_n equals -1 to the power of n minus -1 to the power of n minus 1 plus -1 to the power of n plus 2 for n greater than or equal to 1. Our goal is to find the value of the sum of the first 39 terms of this sequence. A direct calculation of all 39 terms and then adding them up would be very time-consuming. There must be a more elegant way. Let's see if the sequence has a predictable pattern. Let's start by calculating the first few terms of the sequence to look for a pattern. This is a great strategy when you're faced with a new sequence. Let's begin with the first term, a sub 1. We substitute n equals 1 into the formula. This gives us -1 to the first power minus -1 to the power of 1 minus 1 plus -1 to the power of 1 plus 2. This simplifies to -1 to the first minus -1 to the 0 plus -1 to the third. Evaluating these powers, we get -1 minus +1 plus -1. This gives us -3. So our first term is -3. Great, we found the first term. Now let's calculate the second term, a sub 2. Again, we'll use our formula, this time substituting n equals 2. This gives us -1 squared minus -1 to the power of 2 minus 1 plus -1 to the power of 2 plus 2, which simplifies to -1 squared minus -1 to the first plus -1 to the fourth. Evaluating these powers, we get +1 minus -1 plus +1. 1 minus -1 is 1 plus 1, which is 2. Adding another 1, we get 3. So a sub 2 is 3. Okay, we have a sub 1 is -3, and a sub 2 is 3. It's looking interesting. Let's calculate one more, a sub 3. We'll substitute n equals 3 into our formula. This gives us open parenthesis -1, close parenthesis cubed, minus open parenthesis -1 close parenthesis squared, plus open parenthesis -1 close parenthesis to the fifth power. Let's evaluate these. -1 cubed is -1, -1 squared is +1, and -1 to the fifth is -1. So a sub 3 is -1 minus 1 plus -1. This sums to -3. We have found the third term is -3. Let's summarize what we have so far. A sub 1 is -3, a sub 2 is 3, and a sub 3 is -3. Do you see a pattern emerging? The terms are alternating between -3 and 3. This is a periodic sequence with a period of 2. The terms will repeat this -3 pattern indefinitely. So, we found a key insight. The sequence is periodic. Now, how does this help us with the sum of the first 39 terms? We know the sequence is -3, 3, -3, 3, and so on. Let's look at pairs of consecutive terms. What is the sum of a sub 1 and a sub 2? That's -3 plus 3, which equals 0. How about a sub 3 and a sub 4? Since a sub 3 is -3, and a sub 4 will be 3, their sum is also 0. Notice a powerful shortcut here. The sum of any pair of consecutive terms, where the first term has an odd index, is always 0. This is because every odd index term is -3, and every even index term is 3. Generalizing, for any positive integer k, the sum of a sub 2k minus 1 and a sub 2k is -3 plus 3, which is 0. This pair summing to 0 is the key to solving the problem efficiently. We need to find the sum of the first 39 terms. Let's group the terms of our sum into these pairs. The sum starts with the pair a sub 1 plus a sub 2, then a sub 3 plus a sub 4, and so on. The total number of terms is 39. We are forming pairs of 2. How many pairs can we make from 39 terms? 39 divided by 2 is 19 with a remainder of 1. This means we can form 19 complete pairs that each sum to 0, and we will be left with one term that doesn't have a pair. The sum can be rewritten as the sum of 19 zero pairs plus the single remaining term. Which term is the one left over? Well, the pairs cover terms 1 through 38. So the last term, a sub 39, is the one that's left. The sum is equal to 19 times 0 plus a sub 39. This simplifies to just a sub 39. We've made amazing progress. The sum of the first 39 terms is simply the 39th term itself. This is a powerful result of recognizing the periodic nature of the sequence. So, our final step is to calculate a sub-39. Substituting n equals 39 into the formula gives us minus 1 to the 39th, minus 1 to the 38th, plus 1 to the 41st. Now, remember the property of powers of negative 1. Negative 1 to an odd power is minus 1. Negative 1 to an even power is plus 1. 39 is odd, so minus 1 to the 39th is minus 1. 38 is even, so minus 1 to the 38th is 1. 41 is odd, so minus 1 to the 41st is minus 1. Plugging these values back into our expression for a sub 39, we get minus 1 minus 1, plus minus 1. This calculates to negative 3. Let's put it all together to state our final answer. We determined that the sum of the first 39 terms of the sequence is equal to the 39th term, which we just calculated to be minus 3. Therefore, the value of the sum is minus 3. And we solved it without adding 39 numbers. So, what did we accomplish? We successfully evaluated the sum of a sequence. How? By calculating its first few terms to discover a repeating or periodic pattern. The lesson here is that in math, a little exploration can save a lot of work. Always look for patterns.